Welcome to the Tabernas Basin, visited by many. We're coming here to look at one particular system and how it changes from proximal to distal and why that affects things like the position that we would drill our wells. We'll start with here, this location here, near Tabernas town itself, a location called Los Molinos. And what you can see in the background is a cliff. The bottom half is grey, mud. The top half, sort of yellow, brown, which are our sands. And what we've got here, the situation for those who don't know Tabernas, in the south, a sierra, in the north, a sierra, and then around about 5 to 10 million years ago, the whole lot floods, so we all go underwater, which is why there's muds behind us. As the coastlines eventually got established on the sierras, we began to get sediment input coming in, and this is one of the first bits of input to the basin. And you can see it coming down here in the form of a beautiful canyon. And if you look closely, the base of the sands are way up on the top left-hand side of the left-hand outcrop, and as you come down across the face, the base of this big cut, which is really a small canyon, goes deeper and deeper and deeper. And then inside we have the individual fills, many fills, all very coarse-grained. And if you were to really be able to zoom in, you'd see that actually all of those sands, it's sand on sand on sand on sand. So at this point in the system where it's very proximal, very confined, we have almost 100% amalgamation. Okay, so we have a story of amalgamation. We have a small canyon here. It's actually about 300-400 meters wide, mapped out by Kit Cleverland. Let's zoom out and get the perspective here. In that small canyon, we have a number of flows coming down, gradually filling it up. The flows are coming from the north, down into the canyon shape. And if you were to look closely at the sediments, it's pretty coarse. So these are boulders and very coarse-grained sands. And it begs the question, where's the rest of the sediment? And of course, this is a feeder system. So the rest of the sediment is going that direction, around the corner, and that's where we find the main fan system. That's where we're going to go next. Here in the Tabernas Basin, we're now inside the so-called sandy fan, the high net part of the sequence. And we have an idea with the way deep marine systems work. Our first idea is that we have a channel, a canyon system, and then you have a lobe. And we imagine the channel to be sort of channel shaped, and we imagine the lobe as a series of pancakes, which you can have. And in here, we can see that over on this right-hand side of the outcrop here, where actually it is a series of pancakes, many layers, many flows on top of each other, giving us many layers. However, if we pan around, as we go to the left-hand side of the outcrop, suddenly very different. We see a beautiful channel cutting through those relatively well-bedded sandstones. Obviously, the flow properties in the two sides completely different. Order of magnitude better permeability in the channel compared into the pancakes, if we can call them that, or overbanks if you wish. On a gamma ray, they both flatline. When you come to the outcrop, which is one of the reasons we come here, then you can see the heterogeneity. This is a flow-sensitive piece of architecture inside the sandy fan. Pancakes, channels. Sometimes the lobe is highly channelized. Here we are in the middle of the so-called sandy fan in Tabernas. If you were to take a gamma ray through this, it would pretty much flatline. The net gross is 1, to all intents and purposes. It looks pretty homogeneous. When you come in the field and see it, or if you had core through this, you can see that that's not the case. Up here, a beautiful, nice big chunky sand, and then below it, an interval that's much more heterolithic, but it's not mudstone, it's not non-reservoir, it's just heterolithic. But you lose 1 to 2 orders of magnitude permeability. Now, why do we care about this kind of thing? Well, we care because we've got to decide, would you rather have a horizontal well here or a vertical? And we often go for horizontal because it gives us the productivity. Sometimes with disappointment, we don't get the connectivity we're expecting with the aquifer below. And the reason is things just like this. The trick you've seen on previous rock boards, I mentioned kVkh ratios, and my bugbear that they are very, very rarely 0.1. It makes a difference here. You would drill the well in a different position. If you went for a kVkh ratio of 0.1 in this stuff, everything flows nicely through and your horizontal is healthy at the top. If you put a kVkh of 0.01 or 0.001, you lose that connectivity. Much better off with a vertical well or an inclined well. It all hangs on kVkh ratio, but we often assume 0.1, or actually it's much, much lower.